So yesterday I showed you this demonstration. We have our piece of aluminum. This time I do have a bar magnet. I can show you that this is not ferromagnetic. I'm not able to pick this up with a magnet. It is not attracted. I'm making a little pendulum out of it, so it swings quite nicely. But if I set it up to swing through this magnetic field, well, without hitting, it gets stopped. And that is because as that piece of metal is moving, it has a bunch of moving charges. Those charges that are moving through the magnetic field will feel a force, and that force causes them to flow, and it causes current to be created. We call this, we talked about the voltage yesterday, call it the Hall voltage, but it is also related to what we call the Motional Emf. It's the same thing, really. If I have a conductor moving through a magnetic field, as long as the motion is perpendicular to the field, so let's say we have a magnetic field that's pointing out of the board in this region, the charges within that conductor are going to feel forces. So QV, V being to the right, B out of the board, my thumb is down, that means positive charges would feel a force downwards, negative charges would feel a force upwards. So we end up with a net separation of charge, which results or creates an electric field in here. Now with the electric field, the force on a positive charge in an electric field is in the same direction as the field. So what happens is we have a magnetic force trying to push him down. We have an electric force trying to push him up. So we get this battle between the two forces. The electric force will equal the magnetic force. You know the electric force is Q times E. The magnetic force, since we're perpendicular, the magnitude can easily be found by Q dB. Potential difference. Having a separation of charge means there's a potential difference between the two ends, a voltage difference. We call that voltage difference the motional EMF. The symbol we use for the voltage difference is the epsilon, just like we did for the battery, the ideal battery when we were looking at circuits. We know that the voltage in magnitude is equal to the electric field over the distance that these charges are separated by. Sorry, that's not right. It's electric field times the distance. So in place of electric field down here, we can put the EMF over L. So this EMF depends upon how far apart those charges get separated. So the size of the conductor passing through the field. V depends upon how fast that conductor is moving. And B, the magnetic field. This is what we call an induced voltage. There's no battery connected to it. It's not hooked up to the wall outlet. So there's no source, no potential difference that's actually supplied to this conductor, yet it has a voltage difference, and that is because of the motion through the field. So we call it an induced voltage. If this conductor were on some sort of circuitry, for example, if I had a couple of wires that it was lying on, and it was connected across some sort of resistor, that potential difference would actually make current flow. Current will flow from high to low. And we could simply use Ohm's law. The potential difference, in this case the EMF, is equal to I times R being the resistance in the wire. We could figure out how much current was flowing. And that is called an induced current. Because there's no battery, there's no power source, it's all due to the motion of the conductor. They use this concept actually with railguns to accelerate objects. I know they've been looking at railguns for different type of projectile. They use fields to accelerate projectiles, so yeah, launch things into space. Even looking at it in terms of military, some sort of bomb or something, launching it that way. So motional EMF is an induced voltage because of the motion of a conductor through a field, which, if it's connected to a full circuit setup, it can also induce current and cause current to flow. We're going to look at another aspect of induction as well, inducing voltages. Questions on this though, first?